All right, today we're going to talk about the properties of chords, arcs, and central angles and what they are as a reminder. All right, so what is a chord? A chord is a segment connecting 2 points on a circle. So a segment connecting 2 points on a circle. So if I draw a circle, a segment would come here, and it would like connect those 2 points. Or you could have something coming here, but it's just something that connects 2 points on a circle. And note, the diameter is the longest chord in any circle, because it's going directly across. And then just a reminder on some stuff we've done before, but an arc is part of a circle. So if I draw a circle again, an arc would be, like this chunk would be an arc. And then a central angle comes from the center. Of a circle, so if this is your center, this would be your central angle. And then the final note, the measure of your arc is equal to the central angle. So if this was 70, this is also 70. So some more definitions. The congruent arcs theorem. So this says if the central angles are congruent, then the arcs are congruent. Then the arcs are congruent. And then the converse just goes the other way. So if your arcs are congruent, then the central angles are congruent. So if I have a circle, I have like this arc, you draw that. And this arc, and we say that this is 60 and this is 60. That means these two arcs also have to be the same. So let's call this P and Q, and A and B. We could say arc PQ has to be congruent to arc AB. Okay, so the congruent chords theorem, very similar. If your central angles are congruent, then the chords are congruent. So if the central angles are congruent, then the chords are congruent. So the example here, draw in 2 more angles, say these are 60 and 60. That would then mean that these chords right here have to be the same. So we call this A and B and X and Y. AB would have to be congruent to X, Y. And the last one, congruent chords and arcs theorem. So here, if your arcs are congruent, then your chords are congruent. And the same way backwards. So if your arcs are congruent, the chords are congruent. Then the arcs are congruent. So if we had here 2 chords that are the same, then the arcs here have to also be the same. Okay, so how can we use this? So in this diagram, we have 2 circles. We know that BC is congruent to DF. So what could we conclude? we can conclude that these two angles are the same. So angle O has to be congruent to angle P. And then we also know that these arcs have to be the same. So arc BC has to be congruent to arc DF. Last definition. So the chord distance theorem says congruent chords are equidistant from the center of a circle. So congruent chords are equidistant, or the same distance, from the center of the circle. So you draw a circle, and we have two chords that are the same, and this is the center. These are then the same distance, and these are going to be at 90-degree angles. So how can we use that? So here this is 9 and this is 9. So since they're the same length, that means this and this have to be the same. So this is 12.5 and 12.5 for a total distance of 25 when you add them together. This also has to be 25, and that's your answer. Last one here, if you want to figure out what x is, we can look. 18 plus 18 is 36, so these are the same. So x has to be 16, like that. Here's the optional homework. Otherwise, do the 12.2 Math Excel. You only know how to do half of it because the rest of the lesson will be tomorrow. So you can start it, but finish it later.